Step-by-step binder lesson for systems of inequalities. You can either print this out or write this on a separate piece of paper, but I do advise graph paper since a system of inequalities is pretty much just a graphing problem. We don't even really get a numerical response. It's just how do we represent a whole bunch of solutions, because inequalities have lots of solutions on a coordinate plane, and we've got two of them happening at the same time. So with systems of equations, we're trying to represent the one combination of an x and a y that make them both true at the same time. Here we want to represent the region of solutions that make both of these inequalities true at the same time. Okay, go ahead, put your name up there. I'll be Key East today. Today's date is the 4th, or no, it's the 7th for me. And whatever period number you are right there. So sketch the solution to each system of inequalities. So step 1. Step 1, we need to graph the first inequality using its slope and y-intercept. And then just here's a couple reminders. When we graph it, if we have a greater than or a less than, we're going to use a dotted line. If we've got a less than or equal to, or greater than or equal to, I think I said these ones backwards. That's a less than, that's a greater than. Less than or equal to, greater than or equal to, we're going to use a solid line. That's one thing we got to remember. And the other thing is, if we have a less than or equal to, we're going to shade below. And if we have a greater than or equal to, we're going to shade above. All right. Another important thing about step 1 here, we want to graph the first inequality using its slope and y-intercept. We want to shade lightly. I'm going to shade very lightly. Okay, so let's try that with number 1 here. Its y-intercept is a -3, so I put a point at -3. The slope is -4. If you want, you can turn that into a -4 over 1, meaning go down 4 over 1, but that takes us off the graph. So I can also go up 4, 1, 2, 3, 4, and left 1. And that's still a slope of -4. It's still going down 4, right 1 if I go left to right. Let's get another point by going up another 4, left another 1. And then I look, this does not have the or equal to, so it gets a dotted line to connect it. So let me pick a dotted line to go through these points. And then it's a less than symbol, so we want to shade below, shading down here. I picked a very light color, and if you've got your pencil, you're just shading this in very lightly. Hopefully you've got an eraser nearby too, because we're not going to keep this whole region. But what we should think of is this orange region represents all of the solutions to the top inequality. All right, step 2. Graph the second inequality. Again, shade lightly. Okay, so we go back to this problem. I've got a y-intercept of 2. I don't see a slope, so the slope must be a 1, which I could turn into a 1 over 1, which means go up 1, right 1 to make our dots going to the right, or go down 1, left 1 to keep it in a straight line. And then I'm going to connect these dots with a solid line. Check the key right here. That's going to be a solid line. So let me pick a nice solid line. Switch up the color here. And solid line. Okay, I'm staying with that same problem. I now need to shade. This is a less than, so I need to shade below this. I'll shade a different light color, like this light blue. And as I'm shading below that solid green line, let's see, one of those regions got a little bit darker, where I had some overlap. All right, and that brings us to step 3. So, you know, you're almost done here. You could even say that this is your final graph, just as long as you know that we want to keep the overlap. I want to label this as overlap. But I think it looks nice if in step 3, we only keep the overlap and erase all the other shading. Okay, so the overlap, we said, is this region here. So I get my eraser out. And this does kind of a cool thing. It makes it even darker because it's splitting up the shading into individual lines and then saying those lines are overlapping. So I get rid of that. And then I'm going to get rid of this up here. And there is my solution. All right, and so let's talk about what this actually means. This is the combination. Every ordered pair in here is a combination of an x and a y value that'll make both these inequalities true at the same time. We'll double check this one by picking a point that's well inside that shading. I can't really see my points, but I know that -2, -2 right here should be well inside that shading. It's going to make both of these inequalities true. So let's see that top one. -2 is less than, let's see, that'd be an 8 minus 5 is a 5. -2 is less than 5. That works out. Let's check it with the other one. -2 is less than or equal to -2 minus 2 is 0. And that's true as well. I'd rather have $0 in my bank account than -2. All right. So we're done with our steps. Let's just try number 2. Make sure that we are very proficient with our graphing and always remembering to pick the right type of line, and also always remembering to shade on the correct side. Okay, so the top one. I've got a -3 is my y-intercept, so I'm going to put a point at -3. The slope is -2, so that means go down 2, right 1. Or I can reverse it, go up 2, left 1, and I can keep doing that until I've got a line all the way across the graph. It has the or equal to, so I'm going to pick a solid line. I've already got my solid line picked. So I'm going to go across the graph. This is a greater than, so I want to shade above on this one here. Shading above the line. So, you know, pick a point on the line and go straight up, and that's how you get to the above side. All right. Next, this next one has a y-intercept of 2, a slope of 1/2, so rise over run. I'm going to go up 1, right 2, up 1, right 2, or reverse that, down 1, left 2. It keeps us on a nice straight line. This one is just a greater than, so it gets a dotted line. I'm going to pick a dotted line. Maybe I'll do purple. All right. Get a different color, and I want to shade above. This is a greater than symbol, so we shade above. So up here, and we see one of the sections gets a little bit darker. That's the overlap. That's what we keep. So we get our eraser out. We'll make my eraser a little bit bigger this time. And we're going to only keep that overlap. All right, and I'll skip the double check, but you guys know how to double check. Pick a point in this region and plug it into both inequalities. Make sure you get nice true statements. All right, another one. Ooh, this one's a little bit different. We're going to see what happens. Just follow your steps and you will get the right answer here. 1/3 x minus 3, so I put a point at -3. Go up 1 over 3, or down 1, left 3. Connect that up with a solid line. Let's pick a nice solid line here. All right, This one, less than, so we're going to shade lower. So I'm shading down here for this one. All right, next line, it's got a y-intercept of +3, but it has the same slope, up 1, right 3, or down 1, left 3. These lines are parallel because they have the same slope. This gets connected up with a dotted line. So let me pick a dotted line to go through these points here, and then it gets shaded below. So I'm shading below this line. This whole region is not overlapping. The only overlap is down here. All right, so everything below the first line was also below the second line. So that means that when I keep my overlap, I just keep that bottom section. So with parallel lines, you can either end up shading in between the two lines, below one of the lines, above one of the lines, or in some rare cases, we're above this line and below this line, so it's a no solution. So that's how you can get no solutions with systems of inequalities. It is possible. You need parallel lines and a specific order of shading. Okay, there's a couple on the back here. We see one with just an x equals. Let's remind ourselves how to graph that by doing number 4 right now. So first I'll graph that top one though. Point at -3, I'm gonna go up 2, right 3, or down 2, left 3. Connect that up with a dotted line. Got my dotted line picked. And then I'm gonna shade above on this guy. Okay. And then x is greater than or equal to -3. Let's remember how to graph that. So x equals equations create vertical lines. So I need a vertical line that hits the x-axis at -3. So here's my vertical line coming up here. It also goes down here. All right, I'm going to connect that vertical line up with a solid line because it has the or equal to. So solid line coming through here, and then it's a greater than. So one trick with the x equals is this points in the direction that you should shade. This is the greater than side. These are all the x values bigger than -3. And there, one of my regions is getting darker. It's this region in here. You know, these lines split into fourths. It's always 1/4 that gets kept, and the other 2 regions get erased, and one region should not have anything in it already. All right, well, I erased a little bit, but all that should be shaded. You can probably be a little bit more precise with your eraser. We'll skip 5. If you've printed this, you can try 5 on your own. We'll do 6 because it's got that y equals, just to remember how to do that. So y is greater than 1. Y equals equations create horizontal lines. This one's going to cross the y-axis at 1. So it's horizontal. No slope to this. It's like it's y equals 0x plus 1. All right, and that's going to get connected with a dotted line. So I pick out a dotted line. It's a greater than, so that gets shaded above. And that's that for that one. Graph the other one. It's got a y-intercept of -3, slope of -2, so go down 2, right 1, or up 2, left 1. It's going to get connected with a solid line. And I think a lot of the examples we saw had a solid and a dotted line. That's not always the case. You can have 2 solid, you can have 2 dotted. This is a less than, so we're going to shade lower. So below this line here, and there we see our overlap emerging in that top left corner. Eraser, eraser, keeping only this region up here. We can double check with a point in there. We'll call that good for this video. Have a good rest of your day.